Hello, everyone. Thank you for joining and welcome to the presentation end-to-end test automation, but make it efficient. Most teams automate, very few automate well. And today we will talk about what truly makes end-to-end test automation scalable, reliable, and efficient, especially for complex web UI systems, regardless with the use of AI or not. My name is Lilia. I am Head of Quality Assurance at MGM Technology Partners. I am a computer scientist, senior software developer, expert in software quality assurance with the main focus on scalable test automation for enterprise software. I am member of the German Testing Board, and in ISTQB, I am the glossary chair. So today we will be focusing on the top of the test pyramid, the end-to-end tests, and we will mainly talk about web UI automation. Why web UI? Because around 80 to 90% of all UI automations worldwide is web UI. This presentation is grounded in over 12 years of hands-on experience across multiple large-scale projects. I have been leading the end-to-end test automation for more than 32 enterprise applications. Enterprise applications means complex business, long-life applications. So the systems I work with are anything but small or simple. They come from demanding domains such as insurance and also public sector, where reliability, scalability, and long-term maintainability are critical. Out of scope today is the tool selection and also the tool comparison. We will not talk about what is better, Cypress or Playwright. This is out of the scope. Now let's move to the agenda. After a short introduction, we will talk about the key aspects of achieving efficient test automation. So we will start with the component recognition because this is a precondition for successful test automation, followed by how to design automation that requires minimal maintenance. Afterwards, we will talk about test execution, which needs to be stable, flexible, and fast. Then we will discuss test report analysis. This is a recurring, time-consuming, and critical activity, most likely. And last but not least, we will talk about the human factor. So let's start with a quick definition. As related to the philosopher Socrates, the beginning of wisdom is the definition of terms. That's why we start with the definition of end-to-end test automation. So end-to-end test automation is the automated execution of use cases from the end user perspective, not from the developer's perspective. This is very important, this distinction. We simulate in automation the end user's interaction with the application's UI. Ideally, where nothing is mocked anymore in the application. It means this is a holistic validation of the entire application. We simulate real user scenarios and behaviors, and we verify the business processes of the application, primarily to detect critical integration issues before they reach production. That's why we conduct this kind of expensive test automation. Here is a real example of an end-to-end test case at MGM Technology Partners. So you can see this is not just a simple click here, then this appeared scenario. You see a real end user workflow. So first I register in the application. After the login, I navigate to the form and I fill it out with specific test data. Next, I reach the submission page in read-only mode where I check all my input for correctness and completeness. Then after submitting the form, I verify the email confirmation for content accuracy. And finally, I check the PDF content, ensuring that my test data has been transferred correctly and completely. Executing a test case like this typically takes 1 to 5 minutes in automation, depending on the size of the form. In contrast, an average manual tester would usually spend about 20 to 40 minutes on the same scenario. What does efficiency means to me? This is also the title of our talk. Efficiency in end-to-end automation means precise component recognition, high quality test cases that I take in automation, low maintenance of my automation code. It also means test execution that is flexible, stable, and fast, even as the number of test cases grows. And efficiency also includes rapid test result analysis. So these are the core points we will cover in today's talk. Before we dive into automation, let me start with the fundamental prerequisite, which is testability. By the way, testability is a sub-quality characteristic under the quality characteristic maintainability, one of the ISO 25010 quality characteristics. Testability is a non-functional requirement of the system. It is usually defined by the software architect, often in collaboration with the test automation engineer. Testability rests on two key pillars. First of all, we have observability. Observability means the ability to obtain information from the system under test so that we can compare the expected result with the actual result. And secondly, the second pillar is controllability. This is the ability to perform actions on the UI of the system under test. So both pillars are essential if we want to successfully automate end-to-end tests. In case you would like to read more or you are interested to know more, please follow the QR code. It will direct you to the ISC Kubernetes Automation Engineer syllabus, where you can read more about testability and in general about test automation. Now let's start with the first point on our agenda, precise component recognition. This is a critical precondition for successful automation, as I mentioned. So we cannot conduct automation if we are not able to recognize the UI elements accurately and stably. So in the next few slides, I will present some strategic measures that have contributed to accurate, stable, and low maintenance component recognition in my company, and perhaps you can take away some of ideas for your project. So let me start with the first point. To improve testability at MGM, we introduced an HTML attribute called data role. You could name it test ID or test data ID or anything else. The name doesn't matter. What's important is that this attribute is used exclusively for testing purposes, is required. It is a must-have. If it's missing, I generate a bug ticket for the front-end developers, and it must be stable. Is stable, does not change, and it remains consistent across the entire application. This was the first point, and this is not all. So then we developed a small but very powerful software solution, the so-called custom web resolver. The name explains its purpose, so custom, because it's tailored to the specific HTML of the application, of my application. Web, because it's a web application, and resolver because it acts as a mapper. And essentially, it maps the data role attributes on the UI to the classes recognized by the test automation tool as shown in green in the screenshot. The custom web resolver is called once right after open browser window, ensuring that all UI elements are reliably and consistently recognized by the test automation tool. And because the resolver is only one line of code and one time call, so the maintenance is one in one place. And because it's a small component, the maintenance is low and only in one place. As a side note, at MGM, we use the QF test tool for end-to-end automation. In addition, we extended the resolver with scripts to extract useful information from the HTML to enrich the identity of the UI elements. So among other things, we use existing accessibility attributes such as area label and alt attribute because we have to support accessibility because our web applications and e-government have to be by laws accessible. This measure brings two major benefits to us by extending the resolver with these scripts. So first of all, it improves the identification of UI elements, especially those without labels like icon buttons. Then they have meaningful names and meaningful informations. Secondly, it allows us to implicitly test accessibility aspects, ensuring that the application meets at least the basic accessibility standards while performing the end-to-end automation. And here with automation, we can check at least the basic accessibility criteria, the rule-based ones. Furthermore, we introduced class typing to drastically reduce the selection pool of UI elements within the same class. So if I say human child, for example, I am referring to 1/3 of all humans rather than the entire population. By applying class typing where it makes sense, we can significantly reduce the number of targeted elements, improving accuracy and efficiency in component recognition. Let me give you a real example. I have a UI containing many panels. Thanks to class typing, when I say panel header panel, this is the panel on top, I am referring to a single area at the top. And if I say panel footer panel, I am targeting the footer area, which now allows me to accurately maybe recognize the save button in it. Furthermore, if I say panel portal panel, I am pointing always to one unique UI area. Why? Because you cannot have two portal panels visible at the same time. As soon as you leave the input field of the first portal panel to open the second, the first portal panel automatically disappears. We also quickly realized basically that for our customers, the label of an input field usually changes at most one or twice and then remains stable. Based on this, we decided to include the label as part of the component identification. This has two main benefits for us. First of all, the code becomes easy to read, so readability, and easy to understand and to analyze also in the run logs. Secondly, it allows us to implicitly test all labels of the application. We don't have any explicit labels testing. Of course, if your labels are changing frequently, it would not, or I would not recommend this approach. In our case, however, it proved to be a good decision. Now let's look at a situation where I want to target a text field name that exist twice on the UI, once in the contract data section and once in the company section. But I want to interact with the second one. So how do I do that? The answer is simple. I reduce the HTML scope to the company section. I can tell the test automation tool, ignore all the HTML and focus only at the HTML scope, company section. The smaller the scope, the fewer the UI elements it contains, and the more precise the identification becomes. So with the company section, I now have only one. Within the company section, I have now only one single text field name. You see, by narrowing the scope, I eliminate ambiguities and can precisely target the intended UI element. And this is a very helpful and really a very powerful approach to for precise component recognition. For generic usage, component identifications can be parameterized. This brings flexibility, is really powerful. For example, in a multi-language application, the label can be parameterized and assigned depending on the user's locale. For instance, right after the login, all German labels could be loaded and the corresponding IDs are automatically set. This brings flexibility and it reduces maintenance effort immensely. Additionally, there is the possibility to use regular expressions in the identification or even define the entire ID as a parameter. Depending on the scenario, parameterization contributes significantly to flexibility and maintainability. Last but not least, frequently used components can be defined in advance as global variables that can then be used everywhere in your test cases, regardless where. This approach significantly reduces maintenance effort and keeps the code clean and consistent. Now let's talk about the quality of the test cases you intend to automate. So it is important to, before starting automating, to think carefully about the quality of each single individual test case before you begin implementation. Why? Because maintenance is expensive, test execution time is scaling, and I have to think about the value of these test cases. Test cases are, or in general, test artifacts can lead to technical debt if they are not well structured. This is the one thing. And the second thing, this is accumulating. And I have to think, would I like to take a test case in automation without, if you don't think about the design, the test design, you don't have a valuable test case and therefore no valuable automation, but an expensive one. And we don't want to have an expensive automation. We would like to have a valuable one. And this starts firstly with the test scenario. So you have to ask yourself critically, why do I need this test case? What exactly should be tested? What is the focus? What is the added value with this test case? What is the scope? Very important. Secondly, the test data. What data do I need for this scenario? You know, using values like 1, 2, 3, ABC as test data is rarely helpful. It is lowering the value of your test case immensely. Please apply instead proper test design techniques such as equivalence classes and boundary value analysis. Also clarify how your test data will be prepared and reused. This is very important to think about this and solve it. And thirdly, the third pillar of valuable test case is the implementation. Focus on clean code, clear naming convention, modularization, a clean, clear structure. Regardless, you are putting your test case in a test management tool or in a test automation solution, you have to have naming convention and a clean, clear structure. Otherwise, you will have technical depth. So please remember, no thoughtful test design, no valuable automation. It's just an expensive automation. Now that we have built a backlog of high quality test cases, we can finally start the implementation. And at this point, it is highly recommended to prioritize the backlog so that automation begins with the most critical and business related test cases first. Alternatively, you might choose to automate the test cases that bring the greatest relief to your manual QA team, maybe, allowing them to focus their time on testing new and changing features instead. Keep in mind also that automating unstable or frequently changing functionality is rarely a good idea. So the maintenance effort quickly outweighs the benefit, and that's exactly the opposite of efficiency. So begin with the most critical and business relevant test cases is most likely a good approach. Now let's talk about the implementation itself, and more specifically how to design your automation in a way that keeps its maintenance low, it keeps it scalable and efficient over time. And let's start with automating with AI. And AI is just generating the test case for me. I have a planner, I have a generator, and I have a healer. And let me just tell you, test automation is software development. With or without AI, the use of AI, please consider maintainability, reusability, readability, scalability, centralization, redundancy, naming convention, clean, clear structure, all of this. So we need sustainable engineering for our test automation solutions so that we can scale the solution with less maintenance. So it's not about just generating the code because this is the easy thing to do. It is about to establish a solid, scalable, maintainable test automation solution. I repeat, test automation is software development treated as such. Without clean and clear structures, you will very quickly end up with a code jungle, and with it also technical depth. So according to a code red study, this kind of inefficiency costs teams an average of 1 full day per week spent just in searching through messy code. And it doesn't stop there. Onboarding new team members can take up to 4 times longer in such an environment. It's not a good idea. This automation is software development. I just repeated. And like any scalable, maintainable software, it needs a well thought out architecture. What you see here is the test automation framework as it is implemented at MGM Technology Partners. It aligns perfectly with the structure described in the ISTQB Test Automation Engineer syllabus. The framework is built on 3 layers. So the top layer is called core libraries. It includes at the very bottom the libraries provided by the test automation tool. In our case, QF test tool provides a basic library independent of any specific UI. with utility or utility procedures such as table, get, row, count. The tool provides also an accessibility library built on top of AXA Core so that we can automatically also check for rule-based accessibility criteria. It provides a PDF core library for checking the PDF content, and finally an email library to verify email confirmations automatically. On top of that, we have the MGM test automation library, which is project independent. Here we centralize common helper procedures so that every project doesn't have to reinvent the wheel. So we bring efficiency to our projects. Above this sits the project-specific test automation library tailored to the UI and functionality of each project and centralizing helpful project procedures. Then we have the middle layer is the business logic layer, also project and UI dependent. This is where the business logic of the application is implemented and encapsulated. And finally, at the top layer, we have the test scripts. This is where the actual test cases and test suites are developed. These are the ones that are later executed in the CI pipeline. The principle is top-down. It means the top layer can only call the business layer, and the business layer can only call the core libraries. So as you can see, test automation is software development and need a solid architecture. Building a clean, well-structured architecture is essential to minimize redundancy and maintenance effort. Of course, having a clear and well-structured code base is absolutely essential. The classes are typically of the test in the test automation solution are typically organized by business topics, while the packages procedures follow the UI-oriented structure. And on top of that, we apply a consistent naming convention, ensuring that everyone on the team can easily read, understand, and maintain the code, and also later analyze the code in the test report. So for you guys, every one of you is welcome to define their own naming convention. The important thing is it must be applied consistently through the entire test automation solution. So what you see here is my naming convention. The format is simple: action, business. Possible actions include enter and check for any input field, regardless of its technical identity. It can be a picker, it can be a radio button, it can be a text field, a combo box list. I don't care. It's always enter and check. The third possible action is click. It is used for all interactions within the header or footer. And business represents the functional business term written in camel case. Most often it is the label of the input field or the UI heading. So the technical type or of any UI element is irrelevant. And because I know my application, my UI, very well, and follow this clear convention, I can easily navigate through the code similar to the application. It is readable, understandable, maintainable, no searching, no onboarding needed. Everything is self-explanatory. Again, test automation is software development, and that means your code should follow solid design principles and design patterns. Here you see an example of a UI area called employee containing several input fields. For each of these input fields, we implement two modular procedures, one enter and one check. And afterwards, all enter procedures are grouped together into one higher level procedure called enter employee. And only this single procedure enter employee is then used in the test cases and filled with the corresponding test data. Thanks to this modularization and clean structure, the code becomes scalable, easy to maintain, and highly efficient over time. So centralize, parameterize, and modularize and keep a clean structure. This way you continuously ensure low maintenance effort and therefore you lower risk. Why lowering risk? Imagine you have 600 references for, let's say, a component ID across your code base. That's a ticking bomb because if that ID changes during a critical testing phase, when time is already tight, you will be facing a serious problem. Last but not least, sometimes a test case or a test suite needs to be executed under different configurations. Also here it is important not to duplicate the test case, not to duplicate the code. If you catch yourself duplicating with Control-C, Control-V the code, please think about that you are at that moment also duplicating the maintenance effort. Instead, please parameterize the test case so that it can run under different browsers, operating systems, and environments. This way, you keep your automation lean, flexible, and efficient. Now, let's talk about test execution. Our goal is to make it stable, flexible, and fast. Firstly, let's talk about making test execution stable. This starts with reliable component recognition and well-chosen component identification. Also use scopes to restrict the UI area when needed and employ an application busy detector to wait until the application is ready, which is actively waiting rather than using the sleep times. So additionally, actively wait for events like, for example, wait for a component to appear or disappear. Moreover, it's important to ensure that the application or the part under test, the business stuff I would like to test, the part of my application I would like to test is stable by performing, for example, regular build and consistency checks. This saves unnecessary test runs and test analysis for something unstable. Make no sense. It's also crucial to keep the test environment up to date. This is very important. It includes the operating system of my test environment, the test automation tool, the browsers, and any other software needed for testing. And finally, make sure that no parallel activities occur during execution that could interfere with your data or might cause performance issues. If they do, you end up with failing tests that are hard to analyze and valuable time is lost. Secondly, I want test execution to be flexible. This is achieved through modularization. Each test case is treated as a unit and an independent unit separate from other test cases and can be executed at any time. Of course, there are exceptions. Some test cases may change my data irreversibly, requiring a redeploy afterwards, for example. These test cases should be treated separately and remain the exception. The majority should be treated as units, independent units, and this is important. Test suites also are also modular, independent from each other, and split by business topic or subset of functionalities. So each test suite can be rerun at any time. This brings the flexibility. The execution time of any test suite does not exceed X minutes. In my case, it's 60 minutes. This is my own tolerance threshold for a test suite. You are free to set and enforce your tolerance threshold. If a test suite reaches this limit, and because it's modular, it can easily be split into subtopic test suites. So splitting large test suites increases the flexibility and greatly expands your options, especially during critical testing phases. Yeah. Now you can flexibly orchestrate your test suites according to the situations and available time you have. For example, run smoke tests first, then integration tests, and finally broader functional tests, for instance. You can perform an impact analysis and selectively execute only certain test cases, for example. This is also possible and easy to realize. Thanks to modularization, you are prepared at any moment for any situation. You are flexible, and that's what efficiency all about. Thirdly, as the number of test cases scales over time, so does my test execution time. The question is, how can I keep, regardless the scaling of my test, how can I keep the execution time low despite this growth? First of all, actively wait for event rather than just sprinkling sleep times throughout your code, because these sleep times slowly but cumulatively extend the test execution time and therefore inefficiency. So it is important to take the time to understand the UI and its behavior and to implement the right kind of weights rather than using sleep time very quickly. On the right, as you can see, is an example where we actively wait for the restart button to be enabled. And on the left side, you see a real example where the sleep time causes an additional 2 hours, 2 hours in each single test run. It is always your decision to do the right thing and also to monitor and improve continuously the code. Of course, it's important to continuously optimize your test cases. So please eliminate redundant test cases, consistently remove unnecessary steps, and avoid explicitly testing of something of functionalities that are already implicitly covered in other test scenarios, test cases. In short, shed weight smartly wherever possible without compromising the test coverage. Continuously reduce, reuse, and recycle throughout regular code reviews, targeted refactorings. This is very important. Additionally, isolate and optimize unstable flaky test cases and identify and simplify complex procedures in your code. Why? Because every time a test case fails due to such complexity, you have first to dig deep into the code or the algorithm, wasting valuable time that you don't have, especially during the testing phases. And this is also recurring, and this is inefficiency. To make setup and tear down more efficient, please group thematically related test cases, especially those with similar setup and cleanup requirements. This saves valuable execution time. Also, avoid time-consuming setup and cleanup tasks by using efficient methods like database dumps, imports, or any other technical solution that accelerates the setup and the cleanup. Use also small to moderate data volumes to ensure your tests run stably, efficiently, and with lower resource consumption. Generally, it makes no sense to test with, let's say, for example, 10,000 products in every single test case, unless your specific goal is to measure performance under those exact conditions. In most cases, smaller focused test data sets are completely sufficient, while extensive data only increases flakiness and causes unnecessary UI issues. Identify test cases where high runtime, where you have the high execution time but low coverage, low risk. And if you ask me, please eliminate them. You are better off without them. If you insist and you say, I have feelings for this test case, then I recommend decoupling them and executing them only on demand. So let me summarize. Remove redundant tests, perform regular code reviews and targeted refactorings, eliminate inefficient test cases and optimize your data usage. Avoid using sleep times whenever possible. Split oversized test suites and run them in parallel where you can. And finally, if you need to run cross-browser tests, randomize the browser selection. Use random browser. Mathematically, you are covering all of them, but without multiplying your overall test execution time. Let's talk now about the test result analysis, a recurring, time-consuming, and critical activity, as I said before. So during test analysis, it is crucial to quickly recognize known issues and also the tricky follow-up errors so they can be filtered out and unnecessary analysis effort avoided. Additionally, I need sufficient domain knowledge to evaluate situation like is it bug or feature. Moreover, both my application and my automation code must provide clear, meaningful error messages. Otherwise, I will end up spending valuable time digging deep into logs and asking people what does it mean. And this is a recurring activity. So it is accumulating inefficiency. Additionally, because I have applied clean code and a consistent naming convention, parameters, procedures, test case names are clear and self-explanatory, making analysis much faster for everyone. Please also avoid nested identifiers. When the identification depends on multiple combined IDs, if such a line fails, I have to break it apart and test each one individually to find which ID changed, wasting time I don't have during the critical test phases. And this I have to repeat each time this line of code fails. Avoid also complex algorithm or over-engineered logic that requires rethinking every time. And lastly, clearly assign analysis responsibilities within your team. It's counterproductive if multiple people analyze the same test suite unnecessarily. A proven best practice, use a dedicated Jira board. You can start from a template, for example, listing all your test suites that have to be analyzed with each release candidate, for example, all of them with priorities so that you focus first on the critical ones or the higher prior ones. And then everyone in the team can see who is currently analyzing what issues have been found, and which ones are follow-up errors. So you have now, by doing this, no redundant work, no endless communication threads, and this is through efficiency. Last but not least, let's talk about the human factor. The so-called self-inflicted inefficiency. So this includes, for example, forgetting about a known issue from last week and wasting time analyzing the same issue all over again. Another factor might be misusing terminology that leads to misunderstandings. This can be critical and causes extra effort for nothing. You know the saying, wrong words, wrong impact. Another common problem is missing a systematic elimination of causes when analyzing, which makes it harder to find the actual root cause. Instead, during a daily meeting, and this is a real story, this person makes an assumption and states it as a fact. The result, a DevOps engineer or a developer loses half a day investigating somewhere else for nothing, basically based on a false assumption. Even more critical are cases where failures shows up but are not recognized as such, and where workarounds are built around them just to make the automation code run again. Or even worse, to comment out the failing test case, reducing the test coverage and suppressing failures. At the same time, the combination of both is the opposite of successful quality assurance and the opposite of efficiency. A test automation engineer needs knowledge and skills in 4 key areas to work efficiently. First of all, domain knowledge. So depending on the application area, for instance, automotive. So I need to talk automotive language. I have to communicate automotive language every day in the dailies, in the meetings, in the tickets, everywhere. So here it's essential to learn the domain language and its terminology. Secondly, the technical area, including the use of tools, frameworks, programming language, and here the understanding and the correct technical terminology are required. Otherwise, I will produce inefficiency in my team. Thirdly, the fundamentals of software testing, following for sure the ISTQB glossary, the ISTQB terminology, so that everyone shares a common language and a common understanding. So if I say integration test, we are then talking about the same thing. Do not invent a word because you don't know the term. Just open the glossary app and search for the term. In that case, you improve your wording, the wording within your team and within your company. And the fourth point is soft skills, analytical thinking, creativity, intuition, methodology, combinatorial thinking, problem solving, communication, and teamwork. Here we speak the company and or project language. And if, for example, that language is German and my German is poor, I will face limitations. I might misunderstood or miss the context, and that cause inefficiencies. So you see, it's really important to identify the skill gaps within the team and initiate targeted trainings to continuously improve. Let me summarize. Efficient end-to-end test automation isn't magic. It is a discipline, a strategy, and the result of many small, well-considered decisions and proven best practices. Thank you so much for your attention. And remember that test automation is software development, so treat it that way, and it will pay you back with quality, speed, and confidence. It is really dangerous to have false confidence. All tests are green, but these are fluff tests, no high quality test cases, or maybe you are missing stuff. This is false confidence, having Jenkins or whatever your CI tool green, but with no value. I hope you enjoyed the presentation. Thank you for your time and goodbye.